Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 7, Gravitation. Let's move to first question. The time period of a geostationary satellite is 24 hours at a height 6 RE. RE is the radius of Earth from surface of Earth. The time period of another satellite whose height is 2.5 RE from surface will be dash. Here, that is two cases are there. That is T1 square is proportional to R1 cube and T2 square is proportional to R2 cube. That is, this is the law of periods, Kepler's laws of planetary motion, third law of planetary motion. Square of the time period is proportional to cube of the distance. Then R1 is given 6 RE. R1 is given 6 RE plus RE, because from the surface they mention 6 RE plus RE equal to R1 equal to 7 RE. Similarly, R2 equal to 2.5 plus RE, that is 3.5 RE. And what's the other given data? Time period T1 is given 24 hours. Then you want to find the time period of another satellite. So T2 by T1 or T1 by T2 we want to find. T2 by T1. T2 by T1 whole square. T2 square by T1 square whole square I will write. And by taking ratio, proportionality will be changed to equal. Equal to R2 cube by R1 cube. R2 by R1 whole power 3. Substitute. R2 is 3.5 RE. 3.5 RE divided by 7 RE whole power 3. And cancelling this RE and 3.5 2 times. Then 1 by 2 power 3 equal to 1 by 2 power 3 equal to 1 by 8. T2 by T1 whole power 2 equal to 1 by 8. Then T2 by T1 equal to square root of 1 by 8. 1 by root 8. 1 by root 8 you can write as 4 into 2. Square root of 4 is 2. So 1 by 2 root 2. 1 by 2 root 2. And T2 equal to T1 by 2 root 2 and T1 is 24. So 24 by 2 root 2. Then 12. And 12 you can write as 6 into 2 divided by root 2. 2 by root 2 gives root 2. Therefore, this is equal to T2 equal to 6 root 2 hour. That is option A. Option A is the correct answer. Let's move to question number 2. A geostationary satellite is orbiting the Earth at a height of 5 R above the surface of the Earth. R being the radius of the Earth, the time period of another satellite in R at a height of 2 R from the surface of the Earth is dash. Here also, third equation of motion, that is a third planetary motion, T square is proportional to R cube only we are applying. And then T1 square is proportional to R1 cube and T2 square is proportional to R2 cube. Okay. And then R1 equal to 5R plus R. R1 equal to 5R plus R equal to 6R. And similarly, R equal to R2 equal time period of another satellite 2R means R2 equal to 2R plus R. R2 equal to 2R plus R, that is equal to 3R. Geostationary satellite means the time period will be T1 equal to 24 hours. Then substitute that. Here also T2 by T1 only we want to find. T2 by T1 whole power 2 is equal to R2 by R1. R2 is 3R by R1 is 6R whole power 3. R getting cancelled and 3 to 6. Use 1 by 2 power 3, that is equal to 1 by 8. T2 by T1 equal to 1 by 8. T2 equal to T1 is 24 hour we mentioned. 24 by 2 root 2. That is equal to 12 by root 2 is nothing but 6 into 2 by root 2. 2 by root 2 gives root 2. So 6 root 2. 6 root 2 R. It is option C. Option C is the correct answer. Let's move to question number 3. A planet moving along an elliptical orbit is closest to the Sun at a distance r1 and farthest away at a distance of r2. If v1 and v2 are the linear velocities at these points, then the ratio v1 by v2 is dash. Here, that is angular momentum, L1 equal to L2. Total angular momentum is constant, L1 equal to L2. Formula m1 r1 v1 equal to m2 r2 v2. And planet is same planet, so mass is same. m1 equal to m2. Then what you want to find? You want to find v1 by v2. So v1 by v2 equal to m1, m2 same I said. So m1 getting cancelled. m1, m2 getting cancelled because equal to m. And then v1 by v2. v1 by v2 equal to v1 by v2 equal to r2 by r1. r2 by r1. That is option A. Option A is the correct answer. Let's move to question number 4. If the gravitational force between two objects were proportional to 1 by r and r is separation between them, then a particle is circular orbit under such a force would have its orbital speed v proportional to dash. That is, as per the formula, F is inversely proportional to r. Okay, or F equal to k by r, some constant. F equal to k by r. Then the object is moving in a circular orbit. Then what force that is? Centripetal force. What is the formula for centripetal force? mv square by r. mv square by r equal to k by r. Then here r getting cancelled. What you want to find? You want to find v only. That is orbital speed, relation between orbital speed and radius. So v square equal to, what is it? K by m, no? K by m. Or v equal to square root of k by m. Here r is not there. So it means v is independent of r. Independent of r means v is proportional to r power 0. That is option B. Option B is the correct answer. Let's move to question number 5. A body weighs 72 Newton on the surface of the earth. What is the gravitational force on it at a height equal to half of the radius of the earth? That is, h equal to half of the radius of the earth, r by 2. Substitute h equal to r by 2 in this formula. This is the formula g dash equal to g into r by r plus h. And g is the actual acceleration due to gravity. G dash is the acceleration due to gravity at h height. Then substitute this here. G dash equal to g into r divided by r plus r by 2. R by 2 is r plus r by 2, 3r by 2. So r by 3r by 2 I am taking upward. Then r getting cancelled. R getting cancelled. Then it gives 2 by 3 equal to 2 by 3 of g. Is it? Then what is the question? If body weighs, what is the relation between weight and acceleration due to gravity? That is W equal to m into g. Okay. Then W dash equal to multiplied by m on both sides. Multiplied by m on both sides. Then mg dash, that is W dash. W dash equal to mg, that is W into 2 by 3 of g, that is 2 by 3. Then W value, what is the value of W is given here, that is 72 Newton. W equal to 72 Newton. Substitute 2 by 3 of 72. Then 3 2 6, 3 4 12. Or square is the weight. We measure square. Yes. So 2 by 3 of this one means 2 is 4. 4 by 9. 4 by 9. Therefore, here also 4 by 9. 4 by 9 because whole power 2 is there. Here whole power 2. Is it so? Here also whole power 2. Then W by 4, that W into 4 by 9, that is W is 72 into 4 by 9. Then simplify this, 9872, is it so? 9872, 8 into 4, 32. 32 Newton. 32 Newton, that is option A is the correct answer. Let's move to sixth question. A body weighs 200 Newton on the surface of the earth. How much will it weigh halfway down to the center of the earth? Halfway means D equal to R by 2. That is only R halfway. Substitute this here. This is the formula. G dash equal to G into 1 minus G by R. Here G is the acceleration due to gravity on the surface of the earth and G dash is the acceleration due to gravity at D depth. Then D equal to R by 2 substitute. Then G into 1 minus D is R by 2 into R into whole power. And then cancel this R and R. Then 1 minus 1 by 2 equal to G into 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. That is equal to G by 2. This is G dash. Then weight W equal to M into G. That we know the formula. W equal to M into G. So multiply this M G dash equal to M G by 2. Okay. And mg is only given 200. Therefore, this is equal to 200 divided by 2. This is only weight W dash. 200 by 2 is 100. 100 Newton. That is option C. Option C is the correct answer. Let's move to last question. The ratio of escape velocity at Earth VE to escape velocity at a planet VP, whose radius and mean density are twice as that of the Earth, is dash. That is formula V equal to escape velocity V equal to root of 2gm by R. And what is the relation between density, mass and all? Density equal to mass by volume. Mass by volume. Volume is assuming that is the shape of the planet is sphere. So 4 by 3 pi R cube. So from this m equal to 4 by 3 pi R cube into rho, and that if you substitute R cube R getting cancelled, R square, that R square take out of the square root, then R will come. So V equal to R into square root of 8 pi rho g by 3. Here V depends upon only two factors. One is V is proportional to R and also proportional to square root of rho. Okay, and here was given radius and mean density are twice. That is two cases are there. V is proportional to means or V1 is proportional to R1 rho 1 and V2 is proportional to R2 into square root of rho 2. And here given R2 and rho 2 are equal to twice of that. R2 equal to 2 times of R1 and rho 2 equal to 2 times of rho 1. Then what you want to find? You want to find the ratio of escape velocity of Earth. So V1 by V2. V1 by V2 equal to R1 by R2 divided by into square root of rho 1 by rho 2 and R1 by R2. Yes, this is R1. R1 by R2 because V1 by V2 only we are finding and R2 is 2R1. So substitute R1 by 2R1 into rho 1 by 2 rho 1. Rho 1 getting cancelled. R1 rho 1 getting cancelled. Then what you will get? This is equal to remaining thing 1 by 2 root 2. 1 by 2 root 2. That is only V1 by V2 or escape velocity of Earth by escape velocity of planet. That is option A. Option A, 1 by 2 root 2 is the answer. Okay. Okay. Thank you, students. In next session, we will see through next chapter in problem solving session. Thank you.